Hi, my name is Michael Oetken, and welcome to the Technology Leaders Lounge. In this series, we talk about technology, both current technology and emerging technologies. And we talk to some of the experts here on the K-State Salina Aerospace and Technology campus. These folks are working with these technologies every day. And today I have Professor Balaji Balasubramaniam. He works in our Integrated Studies department. And so Bala, welcome to the Technology Leaders Lounge.
All right, thank you. It's been a pleasure to be here.
Cool. So I know you work with a lot of cool stuff, and today I want to talk about cyber physical systems and what that means. So that might be a new term for a lot of people, and so I know that's an area that you're passionate about and that you're doing a lot of research in. So maybe just for the folks out there, just kind of explain what cyber physical systems, what that means.
Sure, yeah. We've been hearing these words more and more often. But it has actually been there for a while. It is first introduced by, back in World War II when Norbert Wiener, an American mathematician, actually coined this cybernetics term. From where we are deriving a lot of words like cyberspace, cyber physical systems, and so on and so forth. During World War II, they were actually trying to do control and communication for automatic aiming of anti-fire guns. So it's been, during that time, they did not even have digital computers,
right? Yeah.
Right? They were able to envision like how the control system will work. And now we are in an era that has been imagined by Norbert Wiener back in, 40, 50 years ago. So when we talk about cyber physical systems, cyber means software and data. Basically any components that we are using, how they are interacting with the world. So that is where this entire cyber physical system came into picture. And we are using many technologies nowadays in each and every field. One example is using these drones, right? Drones, they interact with the world. They gather data from this real world. How do we explore some certain spaces or applications in the military and so on and so forth.
Yeah, cool. I know you've been working on some cool research with these little mini drones that we basically kind of fly indoors. So do you want to talk about kind of what you're doing with these and how that kind of ties into the cyber physical system space?
Sure, yeah. So here at K-State Salina, we are changing the landscape of education. We are giving the students the experience of using these advanced technology in our classroom. And one example is using these mini drones. We are providing students with opportunities like work study opportunities, inside class hands-on projects, and also some research that they can work on. So this is one of the work that my work study student has done. Basically, we are trying to fly this drone autonomously from one location to another location. So let's say it starts from point A, it navigates through the mid-air and then tries to find that point B location and then automatically lands on its own. And here we are using a lot of different technologies, right? So we have the concept of programming, we have the concept of control system and theory. We want to determine the target location using computer vision, and once we have found the target location, then we have to trigger the landing mechanism and finally reach the destination.
Yeah.
So
that's kind of cool. It's using just programming to fly it without a pilot or anybody ever having to manually maneuver it. So I can see that the application for that in a lot of different cases, as far as like I keep hearing about delivery, right? Drone deliveries, and so I'm guessing this kind of concept is what we're looking at for those type of future applications.
Definitely, yeah. So in one of our graduate courses, we are not just trying with one robot, but rather multi-robot. How do the multi-agents communicate with each other? So let's say I put 2 robots inside a maze, and which robot is going to come really fast to find the path out of that maze. So like that, our classroom itself is equipping students to do this real world simulation inside the each of our course materials. So they can, once they graduate, they will be able to apply this in their projects.
Yeah, cool. And so the last piece of technology we have here, so basically looks like a little block here, but this is actually a sensor. Do you want to talk about what you're doing with that technology?
Sure. So this is a leap motion controller. It tries to identify the gesture of our hand using the IR cameras that is there inside it. So you just place it flat, and then you move your hand around. It tries to find each and every fingers and then tries to identify how far you are from this device, and also it allows you to interact with different softwares from there. So for example, let's say you want to control the website scrolling up and down. You don't have to touch the screen. You are completely in the air. You can do it, and we can transform that, which is again our hands-on class project that they are doing. We can also tie this hand gesture motion to the drone for flying back and forth. We can
cool.
Also use it for the virtual reality headset, for which we are nowadays using joystick. Instead of joystick, we can actually replace that using these leap motion devices.
Hands, yeah. So yeah, that's pretty interesting. It kind of makes sense now how the programming side, the software, and the cybernetics ties into the physical hardware and actually your physical hands. And so that's really cool. All right. Well, thank you for spending a few minutes to chat with us about your research, and good luck on everything that you're working on in the future. So again, thanks for being with us.
Thank you. Yeah.
All right. Well, that's all we have for this episode. We'll be talking about a lot of interesting technologies in the future, but for now, we'll talk to you later. Thanks.